Hi students, we will study one more new topic, no? That is thermal expansions. Thermal means what? Heat. When heat is supplied to the substance, what will happen now? It will be able to expand. Why it will expand now? Suppose there is one rod is there, no? Here this one rod, no? So in this rod, what will happen now? All the molecules will be there, no? Like this. These molecules, what will happen now? So these molecules are spaced onto this. Therefore, if you are heating onto this, if you heat it, so what will happen is these molecules will be vibrating. How the heat energy is stored inside the substance? No, it is stored in the form of like a vibrational kinetic energy of the molecule. If you are increasing this heat, therefore, if you are continuously supplying the heat, these molecules are vibrating with a greater amplitude. These molecules will be able to vibrate with a greater amplitude. To get vibrate with a greater amplitude, the distance between the molecules will be increased so that it will be able to vibrate with a greater amplitude. So, if heat energy is increasing, the energy of the molecule is also increasing, it is amplitude is increasing. So, why? Because energy is directly proportional to square of the amplitude. Now, like this, the distance between the two atoms or molecules is increased, like that, small increase like that, what will happen now? The total length of this one slightly goes on increases. Like that, by supplying the heat energy, definitely all the substance will be able to expand. Expand means dimensions are increases now, right? So now let us see. So for solids so there are some type of different type of expansions So like let us see So here we can classify these expansions in the solids in the linear expansion here. So linear expansion. What is linear expansion now? Linear. So you know that linear. What you can tell now? Linear means like a rod. Yes, no? So here the rod is there, just now we discussed, this rod having initial length is Li. So but when it is a temperature is suppose theta1. Now what will happen now when temperature is increased? So therefore it is going to get slightly expands onto this. So why? Because already we studied the distance between the molecules are increased. So final length it will become like a LF when theta is equals to theta 2. So there will be increase in length. What is the increase in length now? So final length minus initial length. Yes, no? Final length minus initial length. This increase in length depends on what factors? Depends on what factors now? This increase in length depends upon the initial length. If initial length is larger, more number of molecules are arranged in that lengthwise. So therefore, the length of the length also it will be going to expansion will be more. Right? If the shorter wire is there, so expansion will be less. So when the longer wire is there, expansion will be larger. That means initial length. And also how much amount of rise in temperature now? If more rise in temperature is there, so definitely so expansion will be also more. So therefore we can rewrite it as delta L is proportional to Li into delta theta. If I remove this proportionality, I have to place one constant, that is alpha into Li into delta theta, right? So alpha, that is coefficient of linear expansion, therefore change in length by initial length into rise in temperature. So what is the unit for this one now? This unit is nothing but a, so length cancel per degree centigrade. Clear? So here one important formula we can rewrite it as for this one. So here delta L by L it will be equal to alpha into delta theta. So delta L by L is nothing but we can write down strain. So this strain is because of due to rise in temperature, that's why you can call it as thermal strain. Clear? So thermal strain is nothing but alpha into delta theta. So also we can write down that is final length minus initial length taken here. So final length it will be equal to, so therefore initial length into 1 plus alpha into delta theta. This is here. So final length we can calculate it. Clear? So this is change in length, this is final length, this is your alpha value, right? So this is about the linear expansion. Similarly, so we can have aerial expansion. So aerial expansion. So similarly, what is areal expansion now? These are the solids no. So this is one area, we can take it as no. So one sheet, okay. So initial area, it is initial area no. Now at temperature is, suppose it is theta 1. Now temperature is increased, what will happen now? Along the lengthwise, along the breadthwise no, it goes to increases. So therefore area also will be increases here now. Therefore area of this one now finally is going to increase. So therefore it is A final at theta 2. So again change in area. So we can depends upon initial area into delta theta. We can remove this proportionality. So delta A, it will be equal to, so area initial, that is nothing but beta into delta theta. Clear? So fractional change in area by A, it is nothing but a beta into delta theta, right? So A final, it will be equal to A initial 1 plus beta into delta theta. This is your areal expansion or superficial expansion. Clear? So now similarly, we can go for volume expansion, or we will call it as cubical expansion, volume expansion. What is the volume expansion? Now exactly the same. You can take it as like a one cube, right? Cube or cuboid. Now initial volume of this one now, it is V1 when theta is equals to theta 1. So final volume V theta 2. So volume is therefore V2. So change in volume, we can rewrite it as change in volume, again the same thing. So you can write it as gamma into V initial into delta theta. This will be your change in volume, or fractional change in volume delta V by V is equals to gamma into delta theta. This is very important formula. Change in volume by original volume is equals to gamma into delta theta, or final volume we can write down, that is nothing but initial volume 1 plus gamma into delta theta. Clear? Right. V final, right. Here we can rewrite it as, so bulk modulus. What is the bulk modulus now? Pressure by volume strain, we can write it now. Similarly volume strain, we can rewrite it as here. So that is nothing but a, here pressure by bulk modulus will be your volume strain, we can rewrite it as now. Clear? So what will be the relation between alpha, beta, gamma now? So here linear expansion, coefficient of linear expansion, coefficient of areal expansion, no? Coefficient of volume expansion is gamma, no? Right? So what will be the relation between them now? For an isotropic medium, isotropic, right? Isotropic medium or isotropic one body, that means it will expand uniformly in all the directions, no? So like that. So alpha is to beta is to gamma is equals to alpha is to 2 alpha, because along the lengthwise, breadthwise, no? Also along lengthwise, breadthwise and height-wise, no? Therefore you can write it as 1 is to 2 is to 3 alpha, beta, gamma, or alpha by 1, that is nothing but beta by 2, gamma by 3. We can write on beta is equals to 2 alpha, gamma is equals to 3 alpha. This is very important, no? So mostly linear expansion. So this is your cubical expansion, this will be your superficial expansion. So this alpha value is not constant here, no? So therefore this alpha value will changes with respect to the temperature, no? This alpha, how it will change now? It will changes like this. So when lower temperature is there, no? Therefore, so here when higher temperatures are there, so it will be able to remain constant. But when lower temperatures are there, so it will be having variable values, no? So we cannot take this alpha value is constant. So it will be changes with respect to the temperature also, right? So but at higher temperatures, we can take it as constant, right? When lower temperature, we cannot take it as constant onto this. Clear? So in this way alpha value will be able to change, right? Always you need not to take the constant. This can be taken constant at only at higher temperatures now. So pure metals will be having like this, no? So slightly higher value. So for like alloys are there, no? This alpha value will be very lesser. And one more important point, this alpha value, right? if alpha value is less here, if alpha is less, so therefore expansion will be less. So whichever there is a devices are there now where you require less expansion, you have to choose alpha value should be very less of that material. Where you require larger expansion, no, alpha value should be taken as large. Clear? So now we will go for some applications no, on this. Observe clearly, most important applications no. Now let us take, there is a one pendulum is there, this one pendulum, simple pendulum no, right. So this string is there no, it is made up of like a metal no, metal. Therefore here therefore it is having length is L. What will be the time period now? Time period is nothing but a 2 pi into square root of L by G. So time period depends on what factors no? Square root of L. So time period is directly proportional to L. So when temperature is increases, what will happen now? Length will be increases. Length will be increases. When length increases, what will happen now? Time period will increase. So time period means what will happen now? This time period means it will take lot of time to go and here no. So therefore here frequency will decrease. Angular velocity will decrease. If it is connected to the clock no, clock will lose the time. Right? So here, so we can calculate now what will be the change in temperature no. So length will not be changed much, right? Very small change. We can use like a error method no. So we can write down delta T by T. So L 1 by 2 means, so L root 2 means, root L means L power 1 by 2 into delta L by L. Delta L by L we know it no. What is the value? Delta L by L is nothing but a alpha into delta theta. That means 1 by 2 alpha into delta theta, right. So change in time, therefore you can write down 1 by 2 alpha into delta theta into T. So this it will be the change in time, or this it will be the fractional change in the time period. Clear? So in this way we can see the effect of temperature on a time period of a simple pendulum. Right. Next one, we will take it as moment of inertia. There is a one rod is there, like you can take like question no. There is a one rod is there, this is one rod. So this rod having mass m and length is L, it is rotated in the middle. What will be the moment of inertia? That is ml square by 12. So when temperature is increased, what will happen now? Here temperature is increased. So therefore here the length of this one is increases. So length increases. When length increases, directly proportional moment of inertia will be increased. Correct? So temperature increases, moment of inertia will be increases now, right? So therefore how to calculate it now? Directly proportional. I is directly proportional to L square, or delta I by I is equals to 2 into delta L by L. Delta L by L is nothing but a 2 into alpha into delta theta, or delta I you can write down 2I into alpha into delta theta. This is your increase in moment of inertia. One more question you can add it here now. Suppose initially it is rotating with an angular velocity is omega 1, moment of inertia is I1. So when temperature is increased, so what happened to the moment of inertia? So when temperature is increased, moment of inertia will be increased. Therefore moment of inertia will become like a I2. What happened to the angular velocity? So it will become like a omega 2. But here there is no torque is acting on this one no. Torque is 0, external torque is 0. So therefore angular momentum will be constant. Angular momentum is constant means what will happen now? I1 omega 1 is equals to I2 omega 2, right. So here moment of inertia is increased. So definitely here angular velocity is inversely proportional to the moment of inertia. So moment of inertia is increased, so angular velocity will be decreased. Clear? So when temperature is increases, so moment of inertia will increase. So but angular velocity what will happen now? Decreases. This is a slightly important concept no. You can remember. Right? So next one. Suppose there is a one rod is there now. This is also one application no. So this one rod is there. So this is clamped at two ends of having length is L, having theta 1 is the temperature. Now what happen now? When temperature is increased, therefore what will happen now? This rod is trying to move out. Therefore this rod is trying to move out onto this. It is going to exert the pressure. It will exert the pressure onto this. With what force it is going to exert now, we want to calculate it. What is the force acting on by this rod on the clamps, right? Here, when temperature increased, so what will happen now? There will be a change in length will be there. Delta L by L is nothing but a alpha into delta theta. You know, Young's modulus. What is the Young's modulus now? That is nothing but a stress by that is strain, right? So this is strain. What you can write it now? This delta L by L is nothing but a strain. So strain you can write down stress by strain or stress by Young's modulus. So this you can take it as now. You can write it as thermal stress. What is the thermal stress formula? So Y into alpha into delta theta. Clear? So thermal stress, what is the formula now? Force by area. So you can write down force is equals to, so area taken now, Young's modulus area into alpha into delta theta. This is your force which is acting when temperature is increased. Clear? When temperature is increased. Clear? So same type of question now, they may ask you like this. There is a one string is there, only one wire is connected. Therefore, it is little bit no tension on this one now. If temperature decreased, what will happen now? This it is going to contract onto this. Due to this contract, no, what will happen now here? So it is going to experience a contraction force, no, it is going to create like a tension on this. So how to calculate the tension here, no? So same formula you can calculate the tension. So this is due to the expansion, the rod is pushing to the wall. This is rod is pushing to this wall, or this is a string is pulling back onto this one now, right? This temperature drop, temperature is increased. Clear? Right. One more application now, you can see. Now, there is a string is there. The string, it is tight, no. Therefore, if you disturb, no, therefore what will happen now? There is a wave is generated here now. This is one wave. Clear? What will be the speed of the wave? Speed of the transverse wave, no? You can write down tension by, it is mu. Right? So mu is nothing but a linear mass density. Tension you can write down tension. What is the formula? Just now written now. Therefore, when temperature is increased, when temperature change, when temperature increase, what will happen now? Okay, temperature is increased, so length will increase, tension will decrease. Okay, so here temperature should be dropped, then tension will increase. Okay, keep in mind. Now what will be the tension here now? Tension is nothing but a Y into alpha into delta theta into A. So mu is nothing but a linear mass density, mass per unit length. Mass is nothing but a density into volume. Volume is nothing but a area into length divided by length. Length cancel. So density into area. Both of you can substitute it now. Velocity it will be equal to, tension is nothing but a Y alpha into delta theta into A divided by, so density into A, this will get cancelled out. So velocity it will be equal to root of Y alpha into delta theta by rho. This is the velocity of the transverse wave when temperature changes. Clear? Now, one more application now. Density. What is the density here now? So density, how the density will change? See here. Density is what is the formula? Mass by volume, right? So when temperature increases, what happen now? When temperature increases, what will happen now? Volume will increase, expands, right? Density, what will happen now? Density will decrease. So we want to calculate the density now. So density is inversely proportional to volume. So density by final density by initial density inversely proportional. Therefore final volume V naught into 1 plus gamma into delta theta. So this is V naught. V naught and V naught get cancelled. So this you can take it common, binomial expansion onto this, 1 minus gamma into delta theta. Actually 1 plus whole to the power of minus 1, or you can write down binomial expansion 1 minus gamma into delta theta. Higher terms you can neglect it now. Density is equals to rho naught into 1 minus gamma into delta theta. This is your density. Therefore, density is this much amount of density is falling. So they may ask you fractional change in the density. So therefore, fractional change in the density, how to do it now? Multiply it now. Change in density minus rho naught by rho naught is equals to minus gamma into delta theta. So this is called fractional change in density. Don't confuse the words change in density. Clear? Fractional change in the density. So this is an important formula. These all are important one now, applications. Let us see one more application here now. So now we'll see. So most of the students know they will confuse here now. See, listen carefully. This is one sheet is there, one sheet. So therefore here we are going to keep it as one hole onto this one. Therefore, if you are this having the radius at certain temperature. Now what you are going to do, when temperature is increased, what happened to the radius? Radius will increase, decrease, remain same, or we cannot say it. Depends on the material. Please answer this one now in the comments. Now most of the students, what they will think, okay, this is expanding, this will come closer. They will think that radius will decrease. But really it is not radius will decrease, it is expands like a uniformly only. So therefore radius will increase, right? So we can calculate the radius now. Therefore here it will be when temperature is increased. So like you can write down area final, that is nothing but area initial 1 plus beta into delta theta, correct? So area is nothing but pi r square, that means r final square is equals to r initial square 1 plus beta into delta theta. This is here. So in this way you can calculate the radius or diameter. You can know the diameter onto this, right? So this also one type of questions now. Clear? Now next one. So we can have one more important question now. Suppose there is a you know that there is a teeth is there, no? These are one teeth. So there is a teeth are there, no? In the teeth, no, therefore there is a one cavities are formed. This one cavity. So when cavity is formed, in this one, no, dentists what they will do, they will fill with some material, no, right? So when you are drinking any coffee or anything, no, the temperature will increase. When temperature is increases, what will happen now? When temperature is increased, so this also will try to expand. It is going to exert the pressure here. We want to calculate the pressure if there is a change in temperature, or if they get the fever also, what is the pressure. So what you can write it now, here change in volume by volume is nothing but gamma into delta theta. So pressure by bulk modulus, right? Pressure exerted by this one now, gamma into bulk modulus into delta theta, right? So many times you can expect this question. This also in one of your NEET or JEE-MAIN no question is came. This gamma, sometimes they will give us like a alpha value, that is 3 alpha also, you can use it onto this. Clear? Now we will do one question here now. Right, one question. So important one no. Let us see, there is a one rod is there, no, this is one rod like railway track rod, no. So if there is no gap is left out, suppose length is L, when there is no gap is left out, what will happen now? When temperature is raised, there is no place here now, what will happen now? So they will be raised somewhere now, right? That's why the gap between the railway tracks no will be left out, right? So suppose it will be formed like this, due to rise in temperature no, it is formed like this. We want to calculate this distance is x. Clear? So at the middle only we want to calculate it. This is formed at the bending onto this. This bending only we want to calculate it. So what is the bending here now? This total length is L. So this length is after this temperature no, that is nothing but a L plus delta L. Correct or not? Right? So this total length is how much now? L plus delta L. But from here to here how much now? This length is equals to L by 2. From here to here it will be how much now? L plus delta L by 2. So you can take it as this is your right angle triangle here no. This is your x. This is L by 2. So L plus delta L by 2. Clear? So you can use Pythagoras theorem. So therefore here x square plus L by 2 square, this one no, this it will be equal to L plus delta L by 2 whole square minus L by 2 whole square. Clear? Simplify this one no, therefore x square, so you can write it as L square plus delta L square plus 2L into delta L minus L square by 4. So this can get cancelled out, but expansion is very smaller no. So therefore here delta L is small, therefore what you can write now, delta L square, it will be still more smaller, very small. So this can be neglected now. What you can write it now, this is x square is equals to, therefore 2L into delta L by 4, this will get cancelled out, therefore L into delta L by 2, right. So therefore here, okay, delta L value you know it no, delta L by L is equals to alpha into delta theta, or delta L is equals to alpha L into delta theta. Please substitute here no, you can get your answer. Therefore L into delta L value alpha into L into delta theta by 2. So what you can write it now, this is x is equals to root of, therefore L square into alpha into delta theta by 2. In this way you can calculate the length value onto this. So these are the one of the smaller applications no. Some more applications are there, so we will discuss in the thermal expansions no, in the next video as a part 1. This is a part 1 and part 2. So one more applications no, we will discuss in the next video now. Okay, hope you understood this one no. Thank you for watching, right. Please subscribe to my channel. Okay, man. Right, thank you.